I'm discussing the first topic of chapter 3, that is the motion in a straight line, which is also called the motion in one dimension. But since the students will be doing this in a new light, so I don't want to use the word one dimensional straight away. After I explain what is one dimensional, then only I'll come into that part. The thing is that motion in a straight line has been taught in junior classes, in whatever be the course, 9th and 10th. You are going to learn about motion in a straight line mostly, but there what happens is that we are not specifying that what is the direction of motion. We talk about what is distance travel, what is displacement, what is speed, what is velocity, what is acceleration, what are equations of motion. These things I am assuming that you know about it. I hope you know about it. Hello?
Hello, ma'am.
So
Yes,
these are things which are known to the students. So the question arises that why are we going to study the same thing again in this class? The answer is that we are going to deal with the entire thing in a different way. For example, like in previous classes, the usual question would be a car travels in 20 meters in 5 seconds. What is its speed? We all are familiar with the definition of speed, how speed is calculated. So we calculate easily as distance by time, and that is 4 meters per second. But what is lacking here? What do you think would be something which is lacking here? Does
it is the direction.
Yeah, it does not tell us anything about in which direction it is moving. The object can be moving this way, the object can be moving the other way, the object can be moving the other way. We don't know anything about it. We just know that it is a distance covered in a certain time, so the speed is this. Now, as long as you are studying in 9 and 10, this is enough. But in 11 and 12, it is not enough. Why not? Because we have to be very specific about what we are talking about. Means we just can't say that it is moving a distance 20 meters in 5 seconds. We have to mention the direction in which it is moving. Now, in mentioning the direction, what we take the help of is basically called frame of reference. Now this word is a jargon, mathematical jargon, which should not bother a student much, because a frame of reference means basically coordinate axis. Basically coordinate, loosely it is the coordinate axis that we are talking about. Now in my slide there are some examples of the kind that one might have solved in junior classes, where the average speed is given as 60 kilometers per hour, 60 kilometers per hour, and the distance for which it is traveling is given as 30 kilometers. On the other half of the journey, the car is moving 30 kilometers, same 30 kilometers, but now the speed is 30 kilometers per hour. So there is a difference. The usual, of course, in junior classes, you might have solved this kind of problem, so many. I am just giving an example to show that nowhere here the distance covered in what direction is mentioned. This problem can be solved. That is not. You want me to solve the problem?
No, not necessarily. You can.
Yes. So this is another example of same kind of problems. These problems are just accumulated on my slide, so that when a student I am teaching for the first time, I can see what is the level of preparedness or whatever. These questions are meant to be a recapitulation of what they have done before. Now, here we are discussing about an example where we are being more specific. This diagram shows a person. If you look at the diagram carefully, you will see that there is kind of a number line, which in any mathematics you must have done a number line. So where you can see that there is a zero somewhere and the person is moving along a number line. And we are not giving the distance traveled directly. We are just stating the position of the person at different interval of time. If I look at the number line, the zero, the origin starts from here. And the person is not at here at time t is equal to 0. Time t is equal to 0 means the time when he starts. He is at a point which is 50 meters or kilometers, whatever be the unit. We can choose a unit. We can choose the unit in this direction to be meter. So he may be 50 meters away from the origin. Look how it makes a difference. Why? Now when he travels in this direction, the distance traveled will be 50 meters when he reaches this origin. But when we calculate the direction, we will calculate the displacement about which you are aware of. You will see that it will have a negative value. So that means, what have I gained by doing this method? What have I gained by doing this method? I have gained that the person starts from a position which is not the point from where I am measuring all my quantities. The person is moving in a particular direction which is understandable by mere calculating the different quantities given. For example, I have written on the slide also, if we consider the origin of our reference frame at 0, it tells us that the man started at position x1 is equal to 50 centimeters. This one, I will not say that it has traveled any distance. I will say his initial position is x1, which is equal to 50 meters. Now, I hope you understand why it is taken as x1. Why not y1? Why not z1 or whatever? Why do we take it as x1? We take it as x1 because usually we take a horizontal direction towards this as a positive direction. Remember your coordinate axis. Remember your coordinate axis. We take x and y coordinate as this, and z of course is perpendicular, and this direction we take as positive, this direction we take as negative, this as positive, this as negative. This is our reference frame. This 0 is here, this 0 is here, this 0. And since we are talking about the motion drift, see, the person is moving along a straight line. He is not changing his angle with the direction of this x. He is changing direction with respect to the distance. Means sometimes he is moving this way, sometimes he is moving this way, but all along he is moving along x direction. So that's why the coordinate or the position is given by x direction, and also it will be considered as motion in a straight line. I hope up to this it's clear.
Yes, ma'am. Yes, ma'am.
Okay, so then now let us look at the various positions. One has to be very careful to look at the time given. It's not that from A to C is the time given. Time he starts from here. The next time is that of when he reaches B. That means he goes from A to B in 3 minutes. What is his position at 3 minutes? His position at 3 minutes is between 10 and 20, which is 15. So I write in 3 minutes that after 3 minutes the position is x2. This is my final position between time 0 to 3. Between time 0 to 3, this is my final position, this is my initial position, and the distance covered is always final position minus initial position, which is equal to, now distance covered I have written minus 35 meters knowingly, because next line I have written the distance covered does not depend, there's a spelling mistake, sorry, here, on direction. So distance I will take only the amount of distance he has traveled, that is 35 meters. If I say what is his displacement, that will be minus 35 meters. It adds to my knowledge in the sense that it tells us that its motion is along minus x direction. Its motion is minus x direction. Though initially people are slightly worried about what to do, why, what is 1D, what is 2D, why do we study 1D, 2D separately? We have studied all this position, velocity, everything before. Why are we studying it again? We are studying it because now, as I told you, that the motion will be considered in various directions in the next chapter when it is a two-dimensional motion. Say, for example, if you we had considered a person moving along a number line. If I consider a plane like the plane of the board, and the ant is moving, on this board, it goes from a position A, it goes to position B, then it goes to position C. It is moving on the board, I can see on the board. At different times I am measuring the position of it. So here no longer the motion is in one straight line. So that simple x2 minus x1 thing will not be there. So how it is done? That is done by vector algebra, which will be done in the next chapter. But it is just an initiation to tell you that this is absolutely required. And basically once you get the hang of it, there is not much to do, because what you have done before, it is almost the same thing. For example, like equation, I'll give you an example of equations of motion. Like in equation of motion, one has studied V is equal to U plus AT, where V is the final velocity, U is the initial velocity, A is the acceleration, T is the time. When we do it in one-dimensional formula, same thing will be there. Let us take the second formula. It comes out better in the second formula. In the second formula, we have done S is equal to UT plus half AT square, where S is the distance traveled. And now see, no longer we are using S here, we are using x2 minus x1, position at time t2 minus position at time t1, time t2 minus t1, here also it should be t2 minus t1, it should be t2 minus t1. And v0 is the initial velocity, 0 stands for the initial velocity, v0 is the initial velocity. So the new form is just a matter of practice. Final velocity is v, initial velocity is v0, acceleration is 2a as it is because acceleration is constant. Of course, in second chapter you will see that we will express it as 2ax, showing that acceleration is in x direction and the distance traveled is x2 minus x1. So I hope this is clear to you. Of course, I have not discussed any questions or whatever.